ml, what is m, ml greater than 5 that we used in problem today. Then you ignore this part. Multiple fins and multiple areas. So anywhere where there is a geometrical complexity, geometry is getting complex, we will try to avoid in exams. Maybe in the tutorials we have done that. Some geometrical complexity, this kind of problem was there. But in major, it will be always simple geometry. So anything related to multiple surfaces, multiple areas, those things you can just ignore. And yeah, adiabatic tip also, you can note down the formula. So this is a table basically. This table you can bring in the formula sheet. Fin efficiency, it's not so important. Okay? Effectiveness only we will stick with effectiveness. Efficiency sometimes confuses people. So we will avoid efficiency and we will also avoid these complicated shapes. Yes. And this you can ignore. This is only for your practical knowledge, not for the exam. Now, again, multiple surfaces we don't need. What else is there? Yeah, so now we come to heat exchangers. Today we did heat exchangers. So heat exchangers, you need to know the log mean temperature difference formula. Heat transfer formula. Heat transfer formula is UA log mean temperature difference. And formula for log mean temperature difference you should know. And you should know simple things like Q is MCP delta T of fluid A is equal to MCP delta T of fluid B. Overall energy balance, that you should know. You should know, or you can write also if you want. And cross flow heat exchangers you can ignore. Okay? Effectiveness you need to know. NTU formulas you need to know. Effectiveness may, there is some correlation. Effectiveness as a function of NTU. There are many correlations given in the book. These things you don't need to write. Don't write in the formula sheet. If the formula is required for NTU versus effectiveness, it will be given in the exam only, like today it was given. So that is for the heat exchanger.
The fouling resistance.
Fouling resistance भी नहीं है. So because we have not solved too many problems on that, but in practical system it is important. That's why it's there. Later on you can think about that. Now transient heat conduction, lumped capacitance. Today there was no problem on lumped capacitance, but you need to cover lumped capacitance. There are many simple problems which you can do by lumped capacitance when the entire object is at a constant temperature. Okay, na? So that formula is this. Theta is exponential t to power t2. There is no Fourier number, there is no Biot number. Those things are not there. So this you need to cover the theory. Then here you know Biot number formula, Fourier number formula, and formula for all the three shapes: slab, cylinder, sphere. This you can bring in the formula sheet. Today it was not given. You can, this all three formulas you can bring. Most likely Bessel function will not be there, but sine and exponential which you can calculate by the calculator, those things are you can expect. Bessel function will not be there. So, but you can still note these formulas, and you will be working with these formulas. An alternative to these formulas are Hausdorff charts, where you don't need to actually calculate the exponential and cos, and directly from the chart you can get the values. But that is all for practical practice. Okay, na? So in exam, Hausdorff charts, concept you should know, but basically you will be using formulas. Hausdorff charts are just an alternate to the formulas. So we will be working with formulas only for the exam. Okay, that's all. I think in the transient. And then semi-infinite solid, completely you can ignore the topic for major. Okay.
Sir, total energy transfer की formula है.
Total energy transfer.
This is plane slab, cylinder.
Yes, that is there. So okay. Yeah, these formulas also you can write. Yeah, these formulas. Sorry, go back to the transient. Transient means total energy content of a body divided by the initial energy content of the body, like the maximum possible energy transfer from the body. That is some simple formulas. These simple formulas you should write and bring. Okay, na? So this is temperature formula. Theta is temperature formula, and Q by Q0 is the energy formula. This you should bring for the three main shapes: slab, cylinder, and sphere. Okay, na? And then semi-infinite you can completely ignore. It is just for your knowledge. And this part two-dimensional also you can ignore. 2-dimensional, just for your knowledge, nothing will come in exam. So in fact, this lecture 26 you can completely ignore. Okay, so then we come to mass diffusion. Mass diffusion, you should know how to calculate concentrations. Concentration is number of moles by volume. So PV is equal to nRT. So N by V is T by RT, where R is R universal. So you should know how to calculate concentration. You should know how to calculate partial pressure, how to calculate partial density. Partial density will be P by RT, where P is partial pressure. Okay? So concentration is P by RT, partial density is P by RT, but here the R is universal. Here R is gas constant, and here R is universal gas constant. So this kind of simple definitions you should know. You can write down and bring the formula for mass flux and mole flux. Diffusivity also you can write, but most likely it will be given in the exam. But you can still write. It's a small formula. Doesn't matter. Mass transfer coefficient, heat transfer coefficient. You can write and bring it. There was one problem in the tutorial about mass transfer coefficient and heat transfer coefficient. And mind you, the measure will not be exactly same what you have solved today. It will be quite different from what we have today. So, yeah, this resistance is just for showing. Don't worry too much about this resistance. Overall diffusion equation is very similar to overall heat equation. I hope you have seen the similarity between heat equation and diffusion equation. Both are very similar. So if you want, you can note one, but mostly in 1D. So all these problems, this will be in 1D. Mass diffusion, everything will be one-dimensional, not two-dimensional. Even the heat conduction also one-dimensional, nothing two-dimensional. So you can write one-dimensional forms of these equations. One-dimensional form, this y term and z term you get rid of, and only x term and production term and change with time. This term you can keep. This we have done today. Mass diffusivity, thermal diffusivity, momentum diffusivity. Bulk fluid motion, this slide is slightly confusing. You have to see in the book to understand properly. And don't just stick to the lecture slides. Lecture slides is only for getting some points, what is covered. But actual discussion, step by step, with text is there in books. Whatever you don't understand, please open the book and see, and you can mail me also if you don't understand anything. But this is there. Evaporation in a column, Stephen flow. Final formula you should write and bring. So for a simple diffusion, formula is this. This is the formula for the simple diffusion. Flux is C dAB grad X. And for the Stephen flow, where there is a column and B cannot move down, A is moving up, and there is a bulk flow, the formula is slightly different. It is not y1 minus y2 by L, it is log of 1 minus y by 1 minus y by L. This formula Stephen flow you should bring. We have solved one problem also in tutorial on this. And yeah, basic Newton's law of viscosity you should know. Three laws: thermal law of conduction, T dt by dx, d dc by dx, and mu du by dy. These three laws you should know. That is all the properties: this dynamic viscosity, kinematic viscosity, and this you should know. Thermal diffusivity, mass diffusivity. Okay, thermal conductivity, Prandtl number, Lewis numbers, and these numbers you should know. Okay, this will be expected, you know. Then I think we can move to convection. Convection mein there was a lot of discussion about getting an intuition, what is happening, what is boundary layer, what is temperature profile, what is velocity profile. We discussed all that. Then we made the governing equations. All these things you can ignore for the exam purpose. It is only for the understanding. So this derivation you don't need to memorize, or you should understand of course, but don't need to memorize. And this is all fluid mechanics, which is a little bit extra, but you should know Reynolds number formula, Prandtl number formula, Nusselt number formula, all the non-dimensional numbers you should know the formula. So that is about the convection. The fluid mechanics was taught, but you don't need to worry about this kind of derivations.
The final equation.
After doing the derivation, what is the final equation? So final results you need to learn. Final results is basically heat transfer coefficient and boundary layer thickness.
The momentum the equation, the energy equation we get finally one dimension. Would that like be useful?
So this is the energy equation,
Equation
but
of-
you don't need to remember the steps of the solution. But final answer basically boundary layer thickness you should know. The thermal boundary layer thickness also you should know. Wall shear stress, friction, these things you can ignore. All the fluid mechanics part you can ignore. Only we'll focus on heat transfer. Okay, so friction will not be there. The thermal boundary layer and momentum boundary layer, this relation you should know. Okay, na? So you should know the concept of boundary layer and what is the formula for boundary layer. So formula for delta is this 5x by square root x, and formula for delta t is delta multiplied by Prandtl number or 1 by 2. So this you should know. Again, the solution should not know, but the final formula which you will be using. Now again, these formulas are too many for laminar flow over a plate, for flow over a cylinder. Now, if you go to the next lecture, there are many cases. So there is a flow over a cylinder, there is flow over a plate, flow over a bank of cylinder, and for every case the Nusselt's number correlation is different. So you don't need to write the Nusselt's number correlation. Maybe one correlation for a flat plate, laminar flow over a flat plate. This one correlation you can, this we have discussed multiple times, you can note down. But for any other case, the Nusselt's number formula will be given in the exam. Like today you have seen in the problem, Nusselt's number formula was given. So that is about the convection. Internal convection also, you should know how to calculate Reynolds number, and for a given Reynolds number, this kind of table might be given. So calculate the Reynolds number, get the Nusselt's number, from Nusselt's number get the heat transfer coefficient, and this kind of things might be there. How does the temperature varies in the case of isothermal wall? How does the temperature varies in the case of constant heat flux wall? So these derivations you should revise. If you want one formula you can note, but there is nothing much to note here. It's mainly understanding the derivation. So this derivation you can practice, internal flow, and these things are extra. This is just for knowledge. Natural convection, you should, again, these equations will not be there. You should know Grashof number and how to use Grashof number to obtain Nusselt's number. Okay. So for Grashof number, properties are there. Beta is 1 by T. That will not be told in the exam. You should know. Beta is 1 by T for gases, and that you should know. And what is?
Like somewhere.
L is the length from the starting where the natural convection is starting from there till the top.
This somewhere they use AC by P.
Yeah, so this is a world of correlations. So depending on the actual geometry, you can do that. But we will keep it exam. We will keep it simple. L will be given directly. L will be length of the plate. So we don't work with ideal surfaces in real world. So real world we have some surface. So we take the area of the surface and some dimension and we estimate a length scale. So those things are there. Now, so this correlation of Nusselt's number with Grashof number, Prandtl number, that will be given in the exam. So don't worry about noting these things. But you should know how to calculate Nusselt's number, how to calculate Grashof number, or there is also Rayleigh number here. Rayleigh number is just Grashof number multiplied by Prandtl number. So you should know to calculate these numbers, but how these numbers are related to each other, the formula will be given. But what length scale to use in a problem, that you should know. What temperature difference to use, that you should know. What alpha, what viscosity, which properties you should use, that you should know. Okay. So again, you can ignore this horizontal plates and this Rayleigh-Bernard. Boiling you can ignore, condensation you can ignore. That is just for your knowledge. Radiation heat transfer may you can ignore anything which is dependent on wavelength. Okay? Radiation changing with wavelength, that you can ignore. But you should know the definition of grey surface, diffuse surface, black body. This kind of definition you should know, which we discussed in the class. This formula you don't need, but of course this formula you remember by heart, you don't need to note it down. Okay? Sigma most likely I'll provide in the exam. This distribution you don't need. And yeah, view factor, how to calculate? This is the main formula for view factor, the final formula. Fij is In cos theta I cos theta j by r square dAj dAi. Okay, so this formula is for the view factor and this formula is for the heat transfer. Basically, it's a symmetric formula. Cos theta I cos theta j dAj dAi, and r is the distance between two surfaces, and now In is the normal direction radiation. Normal direction radiation is epsilon sigma t to the power 4 by I. So main final results from all these things that you can note down and bring. No need to bring the view factors of different geometries. This, if required, it will be given, or it will be common sense. Like for two cylinders, it's a common sense, it is one. Okay? Or it will be given if it is required. Then resistance approach, you can note down the formulas for the resistance and you can bring it. That's all, I think. No need to bring for all the geometries, but just bring one basic formula, which one basic formula like this. 1 minus epsilon A1, A2, these things are there. Then depending on actual geometry, you can change A1, A2. Today it was two cylinders. Later on it might be two spheres or maybe two plates. So A1, A2 will change accordingly. Radiation shield also you should remember, we are solving one problem. Re-radiating surfaces, not for exam. Re-radiating surfaces, and today also we discussed I think this gas radiation participating media. This also not for exam because we are not solving any problem. So that's all. And if you are still in doubt, not clear, you can just mail me what to note, what not to note.